This is a GCSE Physics presentation looking at pressure changes and volume. To get started, what is the difference between heat and temperature? Spend 2 minutes, come up with the best answer you can, and then when you're ready, restart the presentation and check your answer. So pause the presentation now. Well, the difference between heat and temperature is that heat is a measure of all the energy in a substance and it's measured in joules, whereas temperature is a measure of the kinetic energy of each particle, the average kinetic energy per particle, and we use the units degrees Celsius. In this session, we're going to look at how pressure can change the volume of a gas. We're going to apply the equation of pressure times volume as a constant, and for those people sitting the higher only exam, you also need to be aware of how in a given situation we can have work done on an enclosed gas resulting in a change in the temperature of that gas. But that's only if you're doing the higher tier exam. Remember, pressure is when particles hitting a surface, they're exerting a force at right angles to that surface. And the force exerted is what we refer to when we say pressure. What equation links pressure, area, and force? Well, you should know that pressure is the force divided by the area. That means if you increase the force, we have a higher pressure. But if we increase the area, we will decrease the pressure. When particles are in a gas state, they're spread out. We can change the pressure of those particles by pushing them closer together. That means we reduce the volume when we're compressing that particular substance. Or if we expand the volume, increase the volume, we actually allow the gas particles to move further apart, and as a consequence, we would decrease the pressure. Well, what is the standard unit for volume? Well, the standard unit for volume is meters cubed. Volume and pressure are inversely proportional. That means if you increase the pressure, you decrease the volume, and vice versa. If you increase the volume, you decrease the pressure. And you can write it down as a mathematical equation as pressure times volume equals a constant. Now, for that to be true, two other things must be kept constant. They must be unchanged. What two other things can affect pressure and volume? Well, the two things you were looking for are, we have to have a constant temperature, so we're not increasing or decreasing the temperature in the system by adding or removing energy from the system. And we also have to have a fixed mass, so the number of particles in there has to be constant. Remember, in the AQA exam, the equation pressure times volume is constant is actually given to you, so you don't have to memorize it. But again, I always recommend that you do memorize these things to save you the time of having to look them up. Just be aware, when you're dealing with volumes, we're talking about cube numbers. When you're converting 1 meter into centimeters, it's very easy because 1 meter is 100 centimeters. And when you're converting from cubed numbers, 1 meter cubed is 1 meter multiplied by 1 meter multiplied by 1 meter. The width, the height times the depth. Well, if we convert those 1 meters into centimeters, what we'll say is 1 meter cubed is exactly the same as 100 centimeters times 100 centimeters times 100 centimeters. Which if you do, it means that you're actually converting by a factor of 1 million. There are 6 zeros on there. So to convert cm3s into meters 3, cm cubed into meters cubed, what would you have to do calculation-wise? Well, what you have to do is you have to divide the centimeters by 1 million to convert them into meters. If you want to convert from meters into centimeters, then you would multiply by the same number. So let's now have a look at a couple of questions. Remember, when you're doing any of the physics mathematical based questions, the best practice is to find each value, circle that value, and then scribble next to it what that value actually is in terms of mass, of volume, or pressure, etc., etc. You're just going to find it so much more easy to interpret stuff and analyze stuff whenever you've actually identified all the different variables in the question. Well, in this question, the first thing you have to know is you have to be able to know the equation, or at least know that you should look it up on the equation list if you're doing the AQA exam. We then check that all the units are in the correct format. We've got pascals for pressure and meters cubed for volume, so we don't need to do any changing of units. What we then do is we multiply the original 36 pascals of pressure by the 14 meters cubed volume, which gives us a constant of 504. What that means is if we change the volume from 14 to 2, the pressure will change so that we end up with our 504 again. So if we shuffle the equation round so that we can calculate the new pressure, add in 504 as our constant, we divide that by 2 as our volume, means that our new pressure would be 252 pascals. If you were asked to do that in standard form, you need to make sure you can use standard form. You would write it as 2.52 by 10 to the power of 2. Remember, when it comes by 10 to the power of, it's minus numbers. If it's a decimal, if it's bigger than 0, then we will not have a minus up there. It'll be 10 to the power of something as a positive number. In our second calculation, we obviously need the equation. We need to have identified all the variables in there. At this moment in time, you'll notice that we do have an issue with our units because we have 65 centimeters cubed is not in meters. So the first thing we should do is convert that value into meters. Now, if you're comfortable using standard form, you can of course convert that into standard form and use that number, but I prefer to do it as an actual decimal number, and then if I need standard form, I'll do it at the end. So if I've got 65 centimeters cubed, that means I have 0.4 zeros and then a 65 meters cubed. I then have my pressure volume equals a constant calculation. I work out the constant from the before we make any changes to the system. So before we have the 65 centimeters cubed, which we've converted into meters, and our 4 pascals gives us a constant of 0.00026. We then rearrange our equation and we add in our constant from the previous answer, and now we'll have a volume of 7 meters cubed. And as a consequence, we do our calculation and we end up with a new pressure of 0.0000371 if we round off the 3 significant figures. Again, we may be asked to do that in standard form. Remember, in standard form, if it's a decimal, it'll be 10 to the power of minus something. And what you'll find is that you should end up with 3.71 by 10 to the power of minus 5. I would not normally convert into standard form unless the question specifically says give your answer in standard form. You're not going to get any more marks for doing the calculation unless you are asked specifically in the question to write in standard form. Just be aware this next section only applies for those students doing the higher tier exam for AQA. We have this concept called work done. Work done is when we are applying a force to a system resulting in energy transfer. When we have energy being transferred, we say that work is done. When you do work on a gas, we are increasing the internal energy of the gas particles. As we are increasing the internal energy of the gas particles, we in turn will increase the temperature. The question says, what are the standard units for work done? Well, work done, because we're talking about energy transfer, the units are joules. They may ask you about specific examples, but you have to keep that concept of work done, energy being transferred. If energy is transferred, then we're increasing the internal energy of the particles, and as a consequence, we're increasing the temperature. And the classic example is, of course, a bicycle pump. When you push down on the plunger of the pump, you are compressing the air particles inside. Energy is being transferred as you push down, energy is being transferred, therefore work is being done. As work is being done and energy is being transferred, the internal energy of the gas particles inside the container increases. As there's an increase in the internal energy, we have an increase in the temperature. If they ask you about this in the exam, you have to make sure you cover all the steps. You got to walk from the start in terms of work being done. You got to talk about energy transfer. You got to talk about internal energy of the particles, compression, and eventually lead that on to an increase in temperature. What is the equation that links work done, force, and distance moved? Well, the equation is work done equals the force multiplied by the distance moved. So you can actually calculate the energy transferred by working out how far the plunger has moved, the distance, and the force that is applied to the plunger. And then you can actually work out how much energy has been added into the system of particles inside the plunger. Just to finish off, there are 5 terms, there are 5 definitions. All you have to do is match the term to the correct definition. Pause the video. When you're ready, you can restart and check your answers. So pause now. Well, temperature matches with the average internal energy per particle of a substance. Pressure matches with the net force exerted by particles on the surface. Volume is the amount of space occupied by an object. Work done is the amount of energy transferred in a system. And of course, heat is the total amount of thermal energy in a substance.